Good evening, everyone. Good evening. Good evening. I welcome you all again to the NEET Elite. Hope all of you are doing great, having the wonderful time at home. Well, people, if I'm audible and visible to everyone, hit the chat box with the thumbs up. Let me know if I'm audible and visible to everyone fast. Let me know if I'm audible and visible to everyone fast. Yes. Hi, Farouk. Hi, Sahana. Hi, Khushi. Hi, Aryan. How are you guys doing? Wonderful. Let me know with the thumbs ups if I'm audible and visible to everyone, guys. Fast, fast, fast. Yes. Yes. Okay. Hi, Manish. Hi, Yashwani. Hi, Lokanathan. Hi, Manish. Yes, okay, I'm visible. That's great. That's great. That's great. Thank you, Adarsh. Thank you. Thank you so much. All right, so as you all must be knowing, today is our last session from the Ionic Equilibrium part. Yes, and at the same time, in the yesterday's session, we started one more chapter, redox. So people, I will be doing redox and electrochemistry parallelly, right? Okay, I'm going to start one chapter from the 12th portion as well, which is your electrochemistry, right? After this chapter, okay? So before starting the today's session, let me introduce myself. As you all must be knowing, my name is Wassim Sir and I'm your chemistry master teacher right here, right? Okay, so before starting, do like, share and subscribe the channel so that everyone will get benefited out of these sessions, okay? And people, talking about the Vedantu NEET Pro subscription, what all benefits you guys are going to get if you'll enroll yourself in the Pro subscription. You'll get the plans which comes under this Pro subscription. Let me tell you, you guys are going to get 5,000 plus hours of live online teaching. Regular tests and assignments will be provided to you, which contains more than 10,000 questions. We have got 20 plus teachers with 5 plus years of experience will be training you personally for the upcoming NEET 2021 as well as 2022. Yes, and people, at the same time, you have got the complete option to learn either in English or in Hindi. It's completely your wish to select the language, get trained by the master teachers Vedantu in your physics, chemistry as well as biology. Yes. Okay, and people, at the same time, we are going to cover everything which includes your micro as well as crash course. Okay. Yes. Yes. All right. For the ones who are going to appear in the NEET in 2021, we have come up with 3 different plans, and the best part is on every plan you have got 50% off right here. Okay. Now people, the first plan, which is the 1-month plan, after the 50% off, you guys are just getting it for 3750. 3-month plan 11k, 6-month plan 29k. Okay, and on every plan you have got 20% off, and this off is valid just between 20th to 27th of December. Okay. Alright, for the ones who are going to appear in the NEET in 2022, we have come up with 4 different plans as you all can see, and on every plan again you have got 50% off right here. Yes, 1-month plan after the 50% off, you guys are just getting it for 2,500. 3-month plan 6,750. 6-month plan 14k, right? And the 12-month plan you guys are just getting it for 32k. And on all these plans you have got 50% off right here. Okay, and this 50% off is just valid between 20th to 27th of December, right? Okay, now people, for the droppers, again we have 3 plans. On every plan you have got 50% off right here. 1-month plan after the 50% off, you guys are just getting it for 4.5k. 3-month plan 15.5k. 6-month plan 41k. Again you have got 50% off, which is valid just between 20th to 27th of December. Yeah. All right, so how to get enrolled in these batches, how to get these plans, there is the link in your description box. I want you guys to click on that link, use the coupon code as WSPRO. After using this coupon code of WSPRO, you guys are going to get 50% off in whatever plan you're selecting for yourself. Yes, whatever you feel comfortable in, get that plan, get the 50% off by clicking on the link and using the coupon code as WSPRO. All right, now people, tell me, are you super duper excited for this session? Tell me in the chat box, are you super duper excited for this session? Walaikum salam, Sadia. Are you guys super duper excited for this session? Snehal has come up with the quote, it's not stress that kills us, it's our reaction to it. Wonderful, great, yeah, that's actually true. Yes, this is something called as solubility, guys. This is something called as solubility. I'm dissolving NaCl into this water. Yes, yes, you can have a look on it. NaCl is getting dissolved on it, right? Yes, and your solubility, which we are going to discuss in the today's session, is entirely related to this concept which is there on your screen. Yeah. Yes. Thank you. Thank you. All right. Yes, Vijay, this is the last session of our equilibrium, okay? And I'm going to start electrochemistry as well in the upcoming sessions, okay? So I'm going to take redox and electrochemistry parallelly over here. Yes? How we used to take mole concept and equilibrium, in the same way we are going to take redox and electrochemistry right here, okay? First of all, let's finish off this topic, okay? I'm not going into detail of solubility and all. I'm just going to give you the brief introduction about the solubility, and I'll show you how this concept of solubility is applied in the problems. What kind of problems can be asked from this topic of solubility and solubility product in your NEET examination, right? Okay. Yes, Vijay, 12th syllabus is very, very exciting. It's damn exciting. You'll love electrochemistry, trust me on that. Okay. Now, people, first thing about the solubility. How do we define the term solubility? Very, very simple term it is. Solubility is defined as the maximum number of moles per liter which can be dissolved in a solution, right? In a solution, maximum number of moles which you can dissolve in 1 liter of it is what we call as solubility. Yes, very, very, very simple, okay? What does that mean? For example, I have got water in the container. Let's say this is the water in the container which acts as the solvent. Yes? Okay. Now, people, what is going to happen if I'll drop some NaCl to it? What is going to happen? NaCl will start dissolving in this water. NaCl will start to fill the spaces between the water molecules. Between the water molecules, there will be definitely some spaces, right? So NaCl will try to fill the spaces between the water molecules right here, okay? Now, people, the maximum moles of this solute, NaCl, which I'm dropping over here in this water, right? The maximum moles of solute which can be dissolved in 1 liter of the solution is what we call as solubility of some solute over here. Very, very, very simple. So how do we define this solubility? Solubility is nothing. It is just the maximum number of moles per liter of the solution which can be dissolved in the solution. Yes, and let me tell you guys, the solubility, it is represented in moles per liter. Solubility is represented in moles per liter, okay? People, there are few things which I'm going to give you directly which will be using in the questions, yeah? There are few things which I'll be giving you directly in the form of statements, and I want you guys to remember those statements, okay? And I'll be using those statements while I'll be doing questions from the concept of solubility and solubility product, right? Okay, have a look, guys, have a look. Talking about this solubility in detail, first, remember these two things. Solubility is nothing. It is just the maximum moles of solute per liter which can be dissolved in a solution. Yes, and it is represented in moles per liter. It's represented in moles per liter, yeah? Now, talking about few more things. That is the criteria for solubility. Criteria for solubility, okay? Now, people, remember these 3 things as well. These are really important. Whenever solubility value will be greater than 0.1 molar, or you can write it as whenever solubility value is greater than 0.1 moles per liter, yes, we call that salt whose solubility will be greater than 0.1 moles per liter, we call that as soluble salt. We call that as the soluble salt, right? Any salt whose solubility will be greater than 0.01 moles per liter and less than 0.1 moles per liter, we call that salt as slightly soluble salt. We call that salt as slightly soluble salt. Yes. And at the same time, any salt whose solubility will be less than 0.01 molar, we call that salt as the sparingly soluble salt, which I'll be representing by SSS, sparingly soluble salt, whose solubility is going to be less than 0.01 moles per liter, or you can say whose solubility is going to be less than 0.01 molar. Very, very, very simple, okay? So based on these values, we classify we define the criteria for solubility. Yes, on the basis of these values, whenever solubility value will be greater than 0.1 moles per liter, we call it as the soluble salt. Whenever it's going to be greater than 0.01 molar and less than 0.1 molar, we call the salt as the slightly soluble. And whenever it's going to be less than 0.01 moles per liter, we call it as the sparingly soluble salt. Okay? Very, very, very simple. Okay? Now, people, at the same time, one more important thing. In this solubility and solubility product, we have to deal with the sparingly soluble salts. Sparingly soluble salts, we saw, right? Okay, talking about these sparingly soluble salts, one important thing which I want you guys to remember, we treat these sparingly soluble salts same as that of weak electrolytes. We treat these sparingly soluble salts same as that of weak electrolytes. And all of you must be knowing your weak electrolytes, they stay in equilibrium with its ions. In the same way, I'm going to show you a sparingly soluble salt which I'll be treating as the weak electrolyte. I'll be always keeping it in equilibrium with its aqueous ions. Yes. Very simple. Whenever I'll be talking about this sparingly soluble salt, I'll be keeping it in equilibrium with its aqueous ions, right? At the same time, guys, there is something called as saturated solution. There is something called as saturated solution. What is meant by the term saturated solution? Saturated solution is the one in which you cannot dissolve further solute, in which further salt cannot be dissolved. Yes, very simple. Okay. Saturated solution is the one in which further salt, in which no more salt can be dissolved after a certain point. Okay. For example, let's say this is the water in the container. Let's say this is the water in the container, right? And people, understand this statement which I have written over here. In saturated solution, the concentration of ions represent the solubility of a sparingly soluble salt. What does that mean? What does that mean? Understand. Let's say I've got the salt as AB solid. Okay. If it is a sparingly soluble salt, it is going to be in equilibrium with its ions, and its aqueous ions are A positive aqueous plus B negative aqueous. Yes. Yes. Now people, this is some water which I have taken right here, and in this water, let's say I'm dissolving in this water, I'm going to drop this salt AB. This salt AB I'm going to drop in this water, right? Let's assume the water can accommodate 1 mole of this salt. Let's say this water which is in the container, let's say it can accommodate 1 mole of this salt. Okay. So I would say when 1 mole of this salt will get completely dissolved in it, after that, if you will add few more amount of salt, it is not going to get dissolved, right? Because this water, I'm telling you, it has got the capacity to accommodate 1 mole of the salt. If you will drop 1.1 moles, out of 1.1 moles of salt, 1 mole will get dissolved in the solution, and 0.1 mole will be there in the form of precipitate at the bottom. Yes. Very simple. Okay. Now people, understand one important thing. I'm taking, for example, right here 1 mole of salt. Okay. I'm taking 1 mole of this salt AB. Yes. And this water, it can accommodate 1 mole of the salt. Okay. So can I say, if I'll drop 1 mole of salt into this water, this whole 1 mole will be dissolved in this water. And whatever salt I'm going to drop into this water, this 1 mole of salt is going to remain in the form of ions. It is going to remain in the form of ions. Yes, it's going to remain in the form of ions. Right? So very simple. Can I say if the solubility of this salt is 1 mole per liter? Can I say if the solubility of this salt is 1 mole per liter? Can I say the concentration of A positive and B negative is going to be same as 1 mole per liter? Yes. Whatever salt I'm dropping into this, I'm assuming this water can accommodate 1 mole of salt. Okay. And if I'm dropping 1 mole of salt in it, this 1 mole of salt which I'm dropping into this water, this 1 mole of salt is getting dissolved in this water, and this 1 mole of salt will remain in the form of what? It will remain in the form of its ions. Yes. So whatever is going to be the solubility of the salt, same is going to be the concentration of its ions, which is very simple. What does that mean? Understand properly. See, let's say guys, I have got a salt whose solubility is, for example, 2 moles per liter. Its solubility is 2 moles per liter. Yes. So 2 moles of this salt will get dissolved in the solvent. Yes. 2 moles of this salt are going to get dissolved in 1 liter of the solution. I must say that. Yes. So the 2 moles which are getting dissolved in the solution, those 2 moles are going to remain in the form of its ions. Yes. So I can simply say whatever is the solubility of the salt, same will be the concentration of its ions. So concentration of this A positive in the solution is going to be 2 moles per liter. This is again going to be 2 moles per liter, right? I want you guys to remember this right here. Or in general, let me assume like this. Let's say the solubility of salt is S moles per liter. Remember, whatever is the solubility of the salt, same is going to be the concentration of these ions right here. Concentration of A positive right here is going to be S mole per liter. Concentration of B negative right here is going to be S mole per liter. Yes, whatever will be the solubility of the salt, same is going to be the concentration of its ions over here. Yes, Remember this right here, okay? Where I'll be using this concept, guys, it is important. See, first of all, talking about the solubility product, wherein I'll be using the term solubility frequently, okay? Let's say this is, I have got a saturated solution. Let's say I've got the saturated solution of AB, okay? Okay, if it is the saturated solution, remember saturated solution always will be in equilibrium with its ions, okay? Now people, I'm assuming, let's say the solubility of this salt is S moles per liter. If the solubility of this salt is S moles per liter, what is going to be the concentration of this ion? It's going to be again S mole per liter. What about the concentration of this ion? It's going to be S mole per liter. What I told you, the solubility of the salt is going to be same as the concentration of its ions. Yes. Now people, since the reaction is in equilibrium, if I want you guys to write its equilibrium constant, can I write it like this? Concentration of A positive at equilibrium to the power stoichiometry coefficient, concentration of B negative at equilibrium to the power stoichiometry coefficient divided by concentration of AB solid. Yes, concentration of AB solid right here. Okay. Now people, very simple. Okay, see, this KEQ multiplied by this concentration of AB will be equal to concentration of A positive multiplied by concentration of B negative. Now people, this equilibrium constant, it is my constant. This AB, its concentration is the constant. Multiplication of two constants is one more constant, which I'm calling as KSP over here, and KSP is what we call a solubility product. So I can define the solubility product as concentration of A positive multiplied by concentration of B negative right here. Is that clear to everyone? Right? So this is how I'll be writing the KSP expression for a salt which is of the type AB, okay, which is the sparingly soluble salt, I must say right here. Yes. Now people, let's talk about few more interesting things about this solubility product, and I'll show you how to apply this concept of solubility product in the form of questions. Yeah. Okay, I'm not going into detail of solubility. I'm not going into detail of KSP. I'll simply show you the application part. I'll simply show you how questions will be asked in your NEET and how to approach to those questions from here. Yes? Yes? All right. See guys, understand properly what I'm going to say. You got to know KSP of the salt, sparingly soluble salt, is going to be equal product of concentration of its ions raised par their stoichiometric coefficients. Very simple like that. Yeah. Moving on, talking about few important things right here. Let's say I have got the sparingly soluble salt AB over here, correct? Let's say I've got the sparingly soluble salt AB over here. Let's assume the solubility of this salt is S moles per liter. So can I say concentration of its ions are going to be S moles per liter? This is going to be S moles per liter, because I told you whatever is going to be the solubility of the salt, same is going to be the concentration of its ions over here in this type of AB salt. Yeah, very simple. Now people, if I want to write the expression for KSP, as you all must be knowing, KSP will be equal concentration of A positive at equilibrium to the power stoichiometric coefficient multiplied by concentration of B negative at equilibrium to the power stoichiometric coefficient. Yes, I do not have to write this concentration of the reactant over here. I do not have to talk about the reactant over here. Okay, I just have to write the product of concentrations of products raised par their respective stoichiometric coefficients at equilibrium. Yes. Now people, I can write KSP like this. KSP for this salt is going to be, if I'll ask you what is the concentration of this A positive right here, it's going to be S mole per liter. Yes. What is the concentration of B negative right here? It's again going to be S mole over here. So I would say KSP for this salt, which is of the type AB, is going to be simply S square. I want you guys to remember this expression right here, and actually you should know how to make this salt of the expression over here for any salt. Okay, this was my first salt, which was of the type AB. Correct. Talking about few more important salts. Let's say I've got the salt in the form of AB2. Let's say I've got the salt in the form of AB2. First of all, how to dissociate it into the ions, right? See, how many A atoms do I have? 1. How many B atoms do I have? I have 2 B atoms, right? I'll take this 2 as the charge of A. I'm writing it as +2. I'll take this 1 as the charge of B. I'm writing it as -1. Yes. So I got to know there are A positive ions and B negative ions in the solution. Now people, how many A atoms do we have? We have got 1. So I'm starting with 1. And A is existing in the form of A positive. How many B atoms do we have? We have got 2 B atoms, right? And B exists in the form of B negative right here. Okay, this is how we break it. This is how we break it in the form of ions. Yes, I hope you got how to break it. Right? Now we will understand. Let's say the solubility of this salt is S. If solubility of this salt is S, so concentration of this A dye positive is going to be S. But this is 2 times B negative. So should it be S or 2S? It should be 2S. So I got the concentration of A dye positive at equilibrium. I got the concentration of B negative at equilibrium, which is equal to 2S. Yes. Now people, if I want to write the expression for KSP right here, it is going to be simply concentration of A dye positive to the power stoichiometry coefficient multiplied by concentration of B negative to the power stoichiometry coefficient, which is 2. So I got the expression for KSP for this kind of salt as well. Concentration of A dye positive is S. Concentration of B negative is what? It is 2S. 2S का क्या लिया जाएगा? Square. So isn't it going to be 4S cube? Yes. KSP for this salt, which is of the type AB2, is always going to be 4S cube. Yes. Exactly, Karthik. Stoichiometry is used everywhere, which I told you in the beginning as well. Yeah. Moving on to the next type of salt, moving on to the next type of salt, which is of the form of AB3. How to write KSP for this? How to write KSP for this? Okay, first of all, we should know how to break it. I told you how to break it. First of all, I've got 1 A atom, I've got 3 B atoms right here. So I will take this 3 over here as the positive charge. I'll take this 1 over here as the negative charge. So A is existing in the form of A tripositive, B is existing in the form of B negative, right? How many A atoms do we have? 1 A. How many B atoms do we have? 3. That's why I've written 3 over here. This is how I break it in the form of ions. I hope this is clear to everyone. Now people, if the solubility of this salt is S, this is going to be S and this is going to be 3S. Yes, using the stoichiometry. Yes. Very simple. Now people, if I want to write the expression for KSP, as you all must be knowing, it is going to be concentration of A tripositive to the power stoichiometry coefficient of it multiplied by concentration of B negative to the power stoichiometry coefficient of it, that is 3. So I can write the KSP expression over here as concentration of A tripositive is S, concentration of B negative is 3S. 3S का क्या लिया जाएगा? Cube. 3 3 9 3 27. It's going to be 27S to the power 4. This is the expression of KSP for the salt which is of the type AB3. Yeah? Yes. Moving on to one more type of salt, which is A2B3 type, First of all, how to break it into the ions, which you all must be knowing now, right? First of all, this is 2, this is 3. This 3 I'll keep as the positive charge over here. This 2 I'll be keeping as the -2 charge over here. So A is existing in the form of A tripositive, B is existing in the form of B dinegative. How many A atoms do we have? 2. That's why I've written 2 over here. How many B atoms do we have? 3. That's why I've written B over 3 over here. Yes, I'm sure this is clear to everyone. Let's move on and talk about its KSP value. Let's move on and talk about its its KSP value. See, if the solubility of the salt is S, what will the concentration of this A tripositive? It's going to be 2S. What is going to be the concentration of this B dinegative? It's going to be 3S. Yes, using the stoichiometry. Yes. Very simple. Now people, if I want to write the expression for KSP, it's going to be simply equal to concentration of A tripositive to the power 2 multiplied by concentration of B negative to the power what? To the power 3. Absolutely. So I can write the KSP expression from here. Concentration of A tripositive, isn't it going to be 2S? 2S raised power 2 multiplied by concentration of B negative, isn't it going to be 3S? 3S raised power 3. Yes. 2 2s are 4, 4S square multiplied by 3 3s are 9 3s are 27, 27 S to the power 3. 27 multiplied by 4 is 108. Yes, it is going to be 108 S to the power 5 is the expression for KSP for the salt which is of the type A2B3. Yeah. Yes. Is it clear to everyone? Let me know in the chat box fast. I hope this is clear to everyone. I am going to take one salt in general now. Let's say I've got the salt in the form of AXBY. First of all, how to break it into ions. This Y I'm going to keep as the positive charge over here. This X I'm going to keep as negative charge over here. So A is existing in the form of AY positive. B is existing in the form of BX negative. How many A atoms do we have? X atoms. How many B atoms do we have? Y atoms. Yes, this is how I'll be breaking it in the ions. This is how I'll be breaking it in the ions. Now let's talk about its KSP expression, right? Let's say its solubility is S. So it's going to be X times S. It's going to be Y times S using the stoichiometry. Yes. Now people, very, very simple. I can write the expression for KSP from here. Isn't it going to be concentration of AY positive to the power X multiplied by concentration of BX negative to the power Y stoichiometry coefficients? Yes. Very simple. Now people, I can write the KSP expression from here as concentration of AY positive. Isn't it XS to the power X multiplied by what? Multiplied by YS to the power Y. So I can write the KSP value from here as this will be X to the power X multiplied by Y to the power Y. This is S power X, this is S power Y. Isn't it going to be S to the power X plus Y? Yes, this is in general the expression for KSP for any type of salt, for any type of sparingly soluble salt which we'll be having. Let me know in the chat box if it's clear to everyone or not, so that I can move on and do some good questions based on these concepts. Yes, let me know in the chat box fast, guys. Fast. Till then I can have some water. Yeah, let me know in the chat box fast. All right, wonderful. Okay, moving on. Let's try to do few questions based on the concepts of this solubility and solubility product. It's a very simple concept, guys. That's it. See, first thing, what are we supposed to calculate in this question? We are given with the KSP of MgOH whole twice. Yes, KSP value is given as 3.2 into 10 power 14. We have to calculate its solubility in water. Right? What I'll be doing right here is, I'll be simply writing first of all MgOH whole twice. Yes, MgOH whole twice. Yes, if I want you guys to break it into its ions, what its ions will be? Can I say its ions are going to be Mg di positive aqueous, and at the same time it's going to be 2 times OH negative aqueous. Yes, very simple. Yeah. Now people, let's assume its solubility is S. So concentration of Mg di positive should be S, concentration of OH negative should be 2S. Yeah. Very simple. Okay. Now people, if I want you guys to write the expression for KSP, you can do that. Isn't it going to be concentration of Mg di positive raised par stoichiometry coefficient multiplied by concentration of OH negative raised par its stoichiometry coefficient 2? Yes. So KSP value is given to me as how much? It's given to me as 3.2 into 10 to the power what? Into 10 to the power 14. This is going to be equal to concentration of Mg di positive. This is S. Concentration of OH negative. This is 2S. To the power what? To the power 2. Yes. So I got this value as 4s cube. Yes. So I got to know 4s cube is nothing. It is 3.2 into 10 to the power 14 over here. Yes. Yes. Is it clear to everyone, guys? Is it clear to everyone? Let me know fast. Let me know fast. So you can get the s cube value over as 3.2 into 10 to the power 14 into 10 to the power 14 divided by 4. Yes, or you can take cube root on both the sides. You'll be get cube root of this value. Yes, which is going to be, its units are going to be moles per liter. So this is something which we call a solubility, which we were supposed to calculate S value. Yeah. Yes, let me know in the chat box if it's clear. You can do the calculation afterwards, guys. You can do that. Yeah. Okay. Let's move on to one more question. Let me see if you can solve this or not. I've taken this question deliberately, guys. Okay, this is your mercurous chloride. Okay, do not break it in the form of 2 times Hg positive. Do not break it in the form of 2 times something. Okay, always break it in the form of this. Hg2Cl2 gives Hg2 di positive plus 2 times Cl negative. So remember this reaction. This I've taken deliberately over here. Okay, see, first of all, what do we have to calculate? We have to calculate solubility again. Okay, only point over here is to write the reaction, and this is how you write this reaction over here. Yes, exactly, Karthik, you're right. Okay, this is the KSP value which is given to me. Okay, what am I supposed to calculate? I'm supposed to calculate solubility. I'm assuming the solubility of this is S, so this concentration of this is going to be S, concentration of this is going to be 2S. Okay, now people, if I want to write the KSP expression, what it is going to be? It's going to be concentration of Hg2 di positive raised par stoichiometry coefficient, that is 1, multiplied by concentration of Cl negative raised par its stoichiometry coefficient, that is 2. Yes, KSP value is given to me. 10.8 into 10 to the power 23 into 10 to the power 23 is equal. Concentration of this, it is S. Concentration of Cl negative, it's 2S. 2s का क्या लिया जाएगा 2s square. Yes, so again I'm going to get 4s cube is equal to 10.8 into 10 to the power 23. Again I'm going to get the value of s from here as cube root of, or I'll write it like this, 10.8 into 10 to the power 23 divided by what? Divided by 4, and over here I'll take the value as 1 by 3, and its units are going to be in moles per liter. Yes, let me know in the chat box if it's clear to you fast. Yes, let me know in the chat box fast. Yes, or people, you can calculate it as well if you want. You can calculate it as well. Can I write it as 108? Can I write it as 108 into 10 to the power what? Wait, is it 10 power 23 or 10 power minus 23? Just a second, guys. The value should be 10 power minus 23, okay? The value should be 10 to the power minus 23. It should not be 10 to the power 23. Correct? Its value should be 10 to the power minus 23. 10 to the power minus 23. So I'm going to write 108 over here, and over here I'm going to write 10 power minus 24 divided by what? Divided by 4. Correct? This is 4-1, this is 4-2, right? This is 4-7. So 27 into 10 power minus 24 raised power 1 by 3. 27 raised power 1 by 3, all of you must be knowing that is 3. 10 power minus 24 raised power 1 by 3, that is 10 power minus 8. So 3 into 10 power minus 8 moles per liter is going to be the solubility over here, which I was supposed to calculate. Okay? Yes? Yes? Okay? Now people, understand one more thing. I have got one more question right here. Okay? From here you'll be getting one more concept. Okay? See guys, calculate the solubility of silver phosphate. Calculate the solubility of silver phosphate in milligrams per ml, in mg per ml. Correct? In mg per ml. First question in pure water. Second question in a solution that contains 0.02 molar AgNO3. Okay? Very simple question it is. Correct? These are two questions basically. Correct? First of all, KSP of this is given to us as 2.7 in 10 power minus 23. Correct? Calculate the solubility of silver phosphate in mg per ml first in pure water. Okay? First of all, I should know how to break this Ag3PO4. I should know how to break this Ag3PO4. Yes? Ag3PO4, if I'll break it, it's going to be what? It's going to be 3 times Ag positive, 3 times Ag positive aqueous plus what? Plus PO4 tri-negative, plus PO4 tri-negative aqueous. Yes? Yes? Very simple. Okay? Now people, understand. If the solubility of this is S, it is going to be simply 3S, it is going to be S. Yes? By using the stoichiometry. Yeah? By using the stoichiometry. Now people, understand. If I will write the expression for KSP, isn't it going to be concentration of Ag positive to the power 3 multiplied by concentration of PO4 tri-negative over here? Yes. So concentration of Ag positive is simply 3S raised power 3 multiplied by PO4 tri-negative, this solubility is S, and KSP value is given to us as how much? 2.7 into 10 power minus 23. 2.7 into 10 to the power minus 23. Yes. So I'll be getting the value equal to, this will be 27 s to the power 4. Yes. This is going to be 27 s to the power 4 is equal, this is going to be, I'm going to write it as 27 into 10 to the power minus 24. Okay? Can I say this 27 got cancelled. So s to the power 4 is 10 to the power minus 24. So you can write the s value, which is going to be 10 to the power minus 24 raised power what? Raised power 1 by 4. This is going to be moles per liter, which is what we were supposed to calculate. Okay? Yes? Yes? Isn't it simple, guys? Isn't it simple? Yeah? Everything is given. We just have to put the values. That's it. But people, in the second part, the first one was we were supposed to calculate the solubility in pure water, which we have calculated right here. Correct? Now, what to do in the second part? What all differences it's going to create? It's going to make over here. What all differences it's going to make over here? Okay? See, guys. Very simple it is again. Again, I'm going to write the reaction. First of all, I'm going to break this Ag3PO4. This Ag3PO4, I'm going to break into its ions. Its ions are 3 times Ag positive aqueous, 3 times Ag positive aqueous plus PO4 tri-negative aqueous. Yes? Yes, first thing. Now people, I am dropping this silver phosphate in a solution which is 0.02 molar AgNO3. So basically, I'm putting it into AgNO3, and AgNO3, as you all must be knowing, it will get converted to Ag positive aqueous. Yes, and at the same time, it is going to give NO3 negative aqueous. Yes. What is the initial concentration of AgNO3 which is given to me? 0.02 moles per liter, or you call it directly as 0.02 molar. Yes. Initially, it is 0.02 molar. Yes. Can I say it will get completely converted into its ions, and its ions are going to be same 0.02 molar. This will be 0.02 molar. Yes. Now people, understand. Can I say I have the weak electrolyte and the strong electrolyte which have got common ion in between them? Yes. Can I say over here common ion effect will work? Can I say over here common ion effect will work? Yes. And due to the common ion effect, what will happen to the solubility of this salt? Can I say solubility of this salt will decrease? Yes. Solubility salt will decrease. Okay. Now people, if the solubility of this salt will be decreasing, but before that, let me tell you, let's assume its solubility initially was S, correct? It was S. So concentration of this would have been 3S, concentration of this would have been S right here. Okay, concentration of this would have been S. Okay, now I'm putting this AgPO4 into this AgNO3. So what will be the net Ag positive concentration? Is it going to be 3S plus 0.02? Is it going to be 3S plus 0.02? This is the net H positive concentration which we have right here. Yes. Now people, at the same time, due to the common ion effect, what is happening to the solubility? Solubility is decreasing. I am assuming solubility value far less than 1. I'm assuming solubility value to be far less than 1. If I'm assuming the solubility value far less than 1, can I neglect this 3s term in presence of this 0.02? So instead of 3s plus 0.02, I can only write as 0.02. Yes. Now people, I can use the value of KSP. I can use the expression for KSP. I have assumed the solubility to be far less than 1. Okay. I have assumed the solubility to be far less than 1. I have assumed the solubility as less than 5%. Yes. So what I'll be writing? I'll be simply writing the KSP expression. Isn't it going to be concentration of Ag positive to the power 3 multiplied by concentration of PO4 tri-negative over here? KSP value, what do we have to calculate? We have to calculate solubility. KSP is given to us. How much? 2.7 into 10 to the power what? Into 10 to the power minus 23. Yes. Concentration of Ag positive ka square. I'm going to write the concentration of Ag positive as 0.02. Yes. 0.02 ka cube, yes, multiplied by PO4 tri-negative, its concentration is S. So on solving this equation, can I get the solubility over here? Absolutely, yes. Yes, so over here you'll use the concept of the common ion, correct? So I'll be writing 2.7 into 10 to the power minus 23. This is going to be 2 into 10 power minus 2. 2 2s are 4 2s are 8. This is going to be 8 into 10 to the power what? This was minus 2 to the power 3 means minus 6, and this is S right here. Correct? Can you get the value of S from here, guys? Can you get the value of S? Can you get the value of S? S value will be simply 2.7 into 10 to the power what? 10 to the power minus 23. Minus 23 divided by 8 into 10 to the power minus 6 moles per liter. Yes, but people, I forgot to tell you, in the first part we were supposed to calculate the solubility in mg per liter. Over here I got the solubility value in moles per liter. Now how do I convert this moles per liter into mg per ml? How do I do that? It's again a simple thing. Understand that as well. See, solubility value I got as something 2.7 into 10 to the power minus 23 divided by what? Divided by 8 into 10 to the power minus 6. This is moles per liter. Yes. Whose solubility we are talking about? We are talking about the solubility of Ag3PO4. Yes. First of all, in the numerator we have got term mole. In the denominator we have got term liter. First of all, I am going to convert this mole into grams. How do I convert mole into mass? We just have to multiply by molar mass of this substance. What is the molar mass of this substance? Molar mass of Ag, all of you must be knowing, that is 108. 108 multiplied by 3. Yes, phosphorus, all of you must be knowing, that is how much? That is 31. O4 means 64. First of all, this is going to be 24. This is going to be 324 plus 31 plus 64. How much is going to be? 4489, 639 to 11, 3141. Right? This is going to be 419. 419 is going to be the molar mass of this substance right here. If I need to convert these moles into grams, If I need to convert this moles into grams into mass, I'm going to multiply it simply by the molar mass. How much is the molar mass? It is simply as 419. Now the value is in grams, but do I need it in grams in or milligrams? I need it in mgs, so I'm going to multiply it further as 10 power minus 3. Then I'll get milligrams in the numerator. In the denominator, I need ml. 1 liter, as you all must be knowing, that is 1000 ml. 1 liter, as you all must be knowing, that is 1000 ml. Yes, you just have to solve this. You'll get the answer in mg per ml over here. Let me know in the chat box if it's clear to everyone over here. Yes? Let me know in the chat box if it's clear to everyone fast, so that I can move on to a few more important things. Today we are finishing this chapter. I mean, tonight we are finishing this chapter. Okay? Now, people, one more question. Let's do one more question. Let's do one more question. The solubility of Ag2CO3. The solubility of Ag2CO3 at 25 degrees centigrade is 1 into 10 power minus 4 moles per liter. I'm given with Ag2CO3. I'm given with Ag2CO3. It is going to remain in equilibrium with its ions. Its ions are Ag positive aqueous and what? Sorry, twice Ag positive aqueous and what? And CO3 di-negative aqueous. Is it? Yes. Yes, very simple. Now, people, if its solubility is S, this is going to be 2S, this is going to be S, correct? If I want to write the KSP value of it, isn't it going to be 4S cube? Yes, 4S cube value. 4S cube value will be how much? Am I given with the solubility? Am I given with the solubility in water? Yes, I'm given with the solubility in water, which is 1 in 10 power minus 4. So 4 into 1 into 10 power minus 4 ka what? Cube, correct? Very, very, very simple. So I'll be getting 4 into 10 to the power minus 12 value over here. This is the value of what? This is the value of KSP which I got. So first thing which I calculated the KSP of this salt in pure water, which is going to be 4 into 10 power minus 12. 4 into 10 power minus 12. This is something which I calculated right here. Okay. I might need this afterwards. Okay. Now see what I'm going to do. What is the solubility in 0.01 molar Na2CO3? So basically I have got Na2CO3 also over here. I've got Na2CO3 also over here, which will get completely dissociated into 2 Na positive plus CO3 di-negative aqueous. Yes, correct. Now, people, in the same container, I have got this sparingly soluble salt, which is considered as weak electrolyte, and a strong electrolyte, which have got common ion in between them, and the common ion is CO3 di-negative. So over here, can I use the common ion effect? If I'm using the common ion effect, can I say the solubility of this weak electrolyte, solubility of this sparingly soluble salt will further reduce? Yes, solubility of this sparingly soluble salt will further reduce. Absolutely. Okay, let's say its solubility is S. So it's going to be 2S. It is going to be simply S. Yes, very simple. What is the concentration of Na2CO3? Na2CO3 is given as 0.01. Correct? So it is going to completely get converted into 2 times 0.01. Yes, and this is going to be 0.01. Absolutely. Okay. Now, people, what is the resulting CO3 di-negative concentration? It's going to be S plus 0.01. Okay, since due to common ion effect, solubility has further reduced. Yes, and KSP value is very, very small. KSP value is very, very small. So I can assume this solubility, I can assume the solubility to be far, far, far less than 1. If I'm assuming the solubility to be far, far less than 1, so instead of this S plus 0.01, I can simply write as 0.01. I'm neglecting this solubility, which is far, far less than 1 over here. Yes. Now, people, I'm done with the question. What was I supposed to calculate? I was supposed to calculate what? I was supposed to calculate the solubility in 0.01 molar Na2CO3. So can I write the expression for KSP again? Expression for KSP is going to be concentration of Ag positive raised power 2 multiplied by what? Multiplied by concentration of CO3 di-negative. I can write it like this, yeah? I can write it like this. Now, people, KSP value already we got, which is 4 in 10 power minus 12 is equal to Ag positive concentration. Isn't it going to be 2S? This is going to be 2S ka square multiplied by concentration of CO3 di-negative. I'll be simply taking it as 10 power minus 2. Yes, 10 power minus 2. Clear? Now, people, this 10 power minus 2, this 10 power minus 12. So I can get 4S square. This is 2 to the 4S square will be equal 4 into 10 to the power minus 10. Yes. Can I say this 4 and this 4 will get cancelled? Can I get the S value over here simply as 10 power minus 5 moles per liter? Yes. This is the solubility which we are supposed to calculate. Let me know in the chat box if it's clear to you. Let me know in the chat box if it's clear to you fast. Yes. Let me know in the chat box if it's clear to you fast. All right, moving on, talking about this simultaneous solubility, which is the last topic of this chapter, okay? Exactly, Karthik. In the previous questions, they directly give the KSP. Now, over here, we were supposed to find the KSP, yeah? Yes, Vijay, this is the important topic as well. Question frequently comes from this topic as well. It's very simple. Understand properly. See guys, I have two sparingly soluble salts over here. Which are present in the same container. Okay. I have got two sparingly soluble salts right here which are present in the same container. First of all, I'm assuming, let's assume like this. Let X moles per liter be the solubility of this AB solid in presence of what? In presence of AC solid. And at the same time, I'm assuming one more thing. Let Y moles per liter be the solubility of AC solid in presence of AB solid. Okay, both the ones are your sparingly soluble salts. Okay, I'm assuming the solubility of this salt as X moles per liter in presence of this, and I'm assuming the solubility of this salt as Y moles per liter in presence of what? In presence of AB. Correct? Whatever is the solubility of the salt, same is going to be the concentration as we know. Correct? So the concentration of this A positive over here will be X. Concentration of this B negative will be X. Yes, concentration of this A positive will be Y. Concentration of this C negative will be Y. Yes. So people, both these sparingly soluble salts are present in the same container. So can you tell me what will be the resulting A positive concentration? Can I say it's going to be X from this and Y from this? Can I say it's going to be X plus Y? I'm going to write X plus Y over here as well as X plus Y over here. Yes. So the resulting A positive concentration over here is going to be X plus Y. Correct? Yes. Now people, let's assume the solubility product of the first salt right here is KSP1. Let's assume the solubility product for the second salt over here is KSP2. If I'll be writing KSP1 expression, can you tell me what it'll be like? KSP1 will be concentration of this multiplied by concentration of this, which is going to be X multiplied by X plus Y. Yes. KSP2 expression is going to be Y multiplied by X plus Y. Correct? If I divide these two, I'll get an equation which I want you guys to remember. KSP1 divided by KSP2 right here will be equal to X plus Y cancel. So this is going to be X divided by Y. This is the first equation which I want you guys to remember from now onwards. People, if I ask you what is this X? Is this X normal solubility or simultaneous solubility? This X is the simultaneous solubility of this AB in presence of this. Y is the simultaneous solubility of this AC in presence of AB. Okay. This is not the normal solubility. This is the first expression which I got right here. Now people, if I'll simply add these two things, if I'll add KSP1 plus KSP2, what I'll be getting? I will be getting X plus Y ka whole square. If I'll remove the square from here, this becomes root from this side. So this is one more equation which I want you guys to remember. If you remember these two equations, you can solve every equation based on the simultaneous solubility. Okay. Let me know in the chat box if it's clear to you first, so that I can give you a question. With that question, it will be clear to you. It will be clear to you properly. Let me know in the chat box fast. Yes. Do you remember these two equations? Okay. One is KSP1 divided by KSP2 is equal to X by Y. Second is root of KSP1 plus KSP2 is equal to X plus Y. Okay. Very, very, very simple. Yes. Okay. Now people, one more thing. See, this is the question from which you will get this concept cleared, right? A mixture of SrSO4 solid plus BaSO4 solid is shaken with water until equilibrium is established. Given Ksp of this is this much, given Ksp of this is this much, right? Calculate the concentration of each ion at equilibrium. Again, it's a very simple question. Yeah? Yes? Now we will understand. I have got SrSO4 right here, SrSO4 solid right here. I'm considering it to be sparingly soluble salt, so it's going to be Sr di-positive aqueous, and at the same time, you'll be getting SO4 di-negative aqueous. Yes, let's say I have got one more sparingly soluble salt as well. What is that? That is BaSO4. That is BaSO4, right? And the BaSO4, I'm considering it again to be a sparingly soluble salt, and its ions are going to be Ba di-positive aqueous, and at the same time, you'll be getting SO4 di-negative aqueous. SO4 di-negative aqueous, correct? Now, people, I'm assuming, let's say X moles per liter is the solubility of this substance in presence of this, and Y moles per liter is the solubility of this substance in presence of this. So X basically is your simultaneous solubility of SrSO4 in presence of BaSO4. Y moles per liter is the solubility of BaSO4 in presence of your SrSO4. Yes. Now, people, if the solubility of this is X, so concentration of this is going to be X, concentration of this is going to be X. If the solubility of this is Y, concentration of this is going to be Y, concentration of this is going to be Y. Okay. Now, people, which ion is the common? I would say this SO4 is common. So resulting SO4 is going to be X plus Y, and over here I'm adding this X. Correct? Very simple. Okay. Now, Ksp of SrSO4, which I'm representing by Ksp1. Correct? This value is given to me as how much? This value is given to me as 7.5 and 10 power something. 7.5 into 10 to the power minus 7. Yes. Similarly, Ksp2 is also given to me. Ksp of BaSO4 is also given to me. How much is it? It is 6 into 10 power minus 8. It is 6 into 10 power minus 8. People, do you remember the equation? Do you remember the equation which I gave you just now? What was that? That was Ksp1 divided by Ksp2 will be equal to what? Will be equal to X divided by Y. Will be equal to X divided by Y. Yeah. Ksp1 value is given to me. Ksp1 value is given to me 7.5 in 10 power minus 7. This is 7.5 into 10 power minus 7 divided by Ksp2 value is also given to me as 6 in 10 power minus 8. So 6 into 10 power minus 8 is simply equal to X divided by Y. This is one equation which I got right here. This one equation which I got right here. Simply I can make another equation as well. I can make another equation as X plus Y is equal to under root of Ksp of 1 plus Ksp of 2. Yes, isn't it going to be under root of Ksp of 1? Ksp of 1 I can write 75 in 10 power minus 8. 75 into 10 power minus 8 plus what? Plus 6 into 10 power minus 8. I can write it like this. Yeah. I can do that. I can do that. Now, people, I've got two equations, two unknowns. Can we solve these? Can we solve these? Absolutely. See, instead of X, okay, let's try to solve this a bit. See, this 10 power minus 7, this 10 power minus 8. 10 power minus 8 I'll take up. This is going to be 10 power 8. So over here I'll be left with only 10. Over here I'll be left with only 10. Yes, I'll be left with only 10. Or I'll write it simply as 75 divided by X. I'm writing it simply as 75 divided by X. Yeah. X divided by Y is 75 divided by X. Or I can say X is equal to 75 Y divided by X. Yeah. I can do that. Now, instead of X, I can simply write 75 Y divided by 6 plus Y is equal to under root of 10 power minus 8 I'll take common. This is 10 power minus 8 multiplied by 75 plus 6, that is 81. This is 81, correct? So I got the equation, guys. I got the equation. What is the equation all about? 75y plus 6y. 75 plus 6y means 81y. 81y divided by 6 will be equal to root of 10 power minus 8 is 10 power minus 4 multiplied by. This is 81 ka root is 9, correct? Can I get y from here? Y will be simply equal to 6 9s are 54, or let me write it like this. Just a second, guys. This is 9 1s are, this is 9 9s are. Yes, so it's going to be equal to 6 multiplied by 10 to the power minus 4 divided by 9. So I got the value of y. As 6 in 10 power minus 4 divided by 9 moles per liter. You can further solve it. If you got the value of y, value of y, you can get the value of x as well. So the value of x you'll be getting as 75 y by x, y value you have got, put the y value over here, you'll be getting the value of x. Once you get the x and y, can you simply calculate the concentration of all these ions right here? Concentration of Sr di positive is x, concentration of SO4 di negative is x plus y, this is y plus x, this is what we were supposed to calculate. Let me know in the chat box if it's clear to you. Let me know in the chat box if it's clear to you. Let me know in the chat box if it's clear to you. It's okay, Babar, you watch it tomorrow, bro. Let me know in the chat box if it's clear to you. Yes, I'm sure this is clear. So two simple equations you need to remember. One is your KSP1 divided by KSP2 is equal to x by y. Second one is x plus y is equal to root of KSP1 plus KSP2. Okay, very, very simple. Okay, so people, with this I'm ending this chapter. With this I'm ending this chapter. Let me tell you, tomorrow is our session on redox. Okay, tomorrow I'll be starting the calculation of n factors, which is really, really very important. Okay, I'll be talking about equivalent mass, calculation of n factor, and so on. Okay, and people, I'm going to start next chapter in the day after tomorrow's session, which is going to be our electrochemistry. Okay, so I'm going to start the electrochemistry and redox. I'll be taking parallelly. Tomorrow I'm taking redox, day after tomorrow electrochemistry, then again redox, again electrochemistry. Okay, I'll take both the chapters parallelly right here. All right, and at the same time, for the ones who joined us late, let me tell you, we have started with the NEET 2021 crash course in the actual Vedantu platform. You guys can join in if you want to get personally trained in your physics, chemistry, as well as biology. Right, we are going to cover your whole syllabus before your NEET 2021 exam. We are going to personally train you there, and how to get enrolled in this crash course. There is a link in the description box. You just have to click on that link. You have to use the coupon code as WSNET. On using this coupon code of WSNET, you guys are going to get the 20% off right here. And people, there is one more link in the description box. That's for the Telegram. Click on that link as well. Okay, get added to the Telegram group and stay updated about the classes as well. Okay, and at the end, do not forget to like, share, and subscribe the channel so that everyone will get benefited out of these sessions. Okay, people, this was all from my side in the today's session. We are done with the ionic equilibrium. Tomorrow again, let's get back to the redox. Okay, till then, you take care. Bye bye. God bless you all and love you all. Take care, guys. Bye.